Hey, welcome guys. Subject, pre-stressed concrete, and for today we will be discussing the different pre-stressing systems and material properties ng pre-stressed concrete natin. Okay? So, at the end of this session, um, learning outcomes natin would be to differentiate yung two pre-stressing system na meron tayo na I hope you already know based from the first research assignment given to you. And then next is to describe yung properties ng concrete. So for the material properties, we will start first with concrete lang muna. Okay? So the outline of our lesson for today will be just the pre-stressing systems, properties of the hardened concrete, and what are the maximum permissible stresses of concrete based from the NSCP 2015. Okay, so to start, we start with pre-stressing systems. So in pre-stressed concrete structures, pre-stress is introduced by stretching steel wires and anchoring them against concrete. So therefore, the pre-stressing system would comprise essentially a method of stretching the steel and method of anchoring it to the concrete. So in pre-stressing, we have two ways adopted in practice. One is we call it pre-tensioning system, and yung isa is yung post-tensioning system. So yung keyword is yung kanyang prefixes, no? Yung pre and post. So basically both of them are applying stresses dun sa steel dun sa tension wires natin, pero ang pinagkaiba nila is yung sequence kung kailan nag-i-stressing, no? So start muna tayo sa pre-stressing or pre-tensioning system. Okay? So for pre-tensioning system, the pre-stressing is induced before the concrete is placed. So as you can see here on the right side, meron tayong tinatawag na abutment. So yun yung nag-hold dun sa mismong steel wire natin. And then ang ginagawa is nag-a-apply na tayo ng jacking force o meron tayong device na tinitwist yung mismong steel natin, ni-stretch or ni-stress natin para ah, ma-induce yung force na gusto natin, no? And then once na nailagay na natin yung ah, required o yung desired strength natin, we will let the wire rest dun sa location niya, dun sa abutment o dun sa guide, uh, yung bulkheads or guide boxes na to. Okay, this is sa ends niya. And then, pwede na tayo mag-cast ng concrete. So, while casting ng concrete, this will be the condition like shown in part B. So, syempre may formworks naman yun. Ano? So, ito section itong pinapakita natin. And then, once na nag-harden yung concrete or once na-achieve na natin yung desired strength ng concrete, we can now cut yung wires natin slowly, no? To release yung pre-stressing natin. So, mangyayari, since stress yung wire natin, both side, o sa isang end, or sa both ends, ang nangyayari, once na kinat natin siya, ang tendency niya is to go back to its original shape. Ngayon, since may bonding ng concrete and the wire, napipigilan yung kanyang pagbalik to sa original na na size niya or yung original length niya. Kaya mangyayari nag-i-induce na ng ano siya ng compressive stress, no? Kaya kapag halimbawa yung tendon natin like we have discussed last session, kapag naka-eccentricity yung mismong tendon natin, like for this case, nag-i-induce siya ng moment kaya nagkakameron siya um, ng negative moment dito or nagka-camber tayo o nagda-deflect siya pataas, no? So ito medyo yung condition nito is medyo exaggerated lang for viewing yung nangyayari, pero pwede din mangyari ito sa site, no? If especially kung sobrang haba ng length ng member natin. And then magiging balance to once na in-apply na natin yung load, babalik siya doon sa original niya location as shown doon sa letter B. Okay? So again, the concrete is placed while maintaining yung tension. Then when concrete is hardened sufficiently, the tendons are released. And this type of pre-stressing is commonly used for small size members only, katulad ng mga beam slabs, piles, slippers, and electric poles, which can be casted easily in factories. So meaning, yung pag pre-tensioning yung ginagamit, pwedeng hindi dun sa actual construction site gawin. Pwedeng before delivery sa site, nilalagay na natin agad yung kinakas na natin sa isang location yung mismong member natin. Then once casted na yung member natin, ita-travel na lang yun through transport na lang, delivery na lang. So usually mapapansin natin to doon sa mga modular na construction, no. Usually upon pagdating sa site, nakatayo na yung main frame ng mismong structure, and then halimbawa slab yung naka-pretension, edi kinakasa na lang siya dun sa site. Okay? So let me share a video showing yung pretensioning system on site. Okay? So let me share yung video. So this is a video from YouTube lang din naman. So credits dun sa owner ng video. Let me check. So, okay, so for pre-tensioning. Okay. Yeah, so let's all watch this. Okay, so yun yung simple procedure ng pre-tensioning, no? Recap lang natin. So yung ginawa niya, like nung na-discuss ko na din earlier, we have a location for pre-tensioning. So meron tayong designated location for that. So dito, una nilang ginawa is prepare yung lalatagan ng mismong wires natin. Then after preparation, so tinanggalan ng mga debris, no, na pwedeng nakaharang sa kanya, kaya nililinis siya. Ito, like this one. So ito yung paglalagyan mismo ng mga pre-stressed slab siguro yan, no? Okay. And then yan, yung wires nilalagay tapos kinakat na lang siya ng may meron siyang bulkhead dun sa dulo, no, na nandun yung nagko-control sa kanya o naghahawak sa kanya. Yan, to. Once na pinre-stress natin siya. So kung makikita natin doon sa next nito, yung ginagamit niyang may gauge is ginagawa lang nun is nag-a-apply ng torque dito para hilahin yung mismong wire natin, kaya makikita nyo humahaba yung length ng wire dito kasi nga hinihila niya yung buong uh, buong wire natin para ma-stress siya. Okay? Then once na na-achieve, ilalak lang yun dun sa mismong anchor niya para i-position niya itself yung wire habang inantay natin mag-cure yung concrete. Then once the concrete was cured, kinakat na lang siya. Okay, then ready for transport na siya. Okay. So dito kung makikita nyo, pakita ulit natin to. Paano nyo ginagawa. Okay, so yan. Pinapasok niya dun sa instrument yung mismong wire, and then makita natin yan. Gumalaw yung wire dito, meaning hinihila na niya yung mismong wire natin para ma-apply yung stress na kailangan natin. Okay. Then after magkameron, yun na, for transport na siya, as shown dito. Okay? Ayan. Okay? So yun yung sa pre-tensioning. So let's go back dun sa slide natin. Ayan. So kaya ang ano din niya, isa sa advantages niya, kahit may ginagawa tayong ibang activity dun sa site, pwede natin makast yung mismo element natin. Okay? Pero ang limit niya, usually for small size members lang siya ginagamit. Okay? Then we have yung advantages and disadvantages niya. So yung advantages niya, less expenditure on equipment or materials. Kasi yung anchorage niya, no, hindi siya katulad kapag mamaya do sa isang system natin na mas mahal yung gastos do sa paglalagay nung mismong tension wire, no? Kasi before siya magkamero nung hindi siya exposed dun sa mismong concrete natin na diretso. So meron pa siyang ginagamit na sheet para protektahan yung mismong tension wire natin. Okay? Then also, isa pang advantage niya, may mas certain yung pre-stressing force natin dito kasi control natin dun sa ends yung sa anchors natin and dun sa applied nung instrument natin. Okay? So, more reliable yung pre-stressing force and yung transfer niya is mas nakokontrol natin. Disadvantage is yung abutment natin o yung ends natin must be strong enough to hold yung mismong force. Halimbawa, masyadong malakas yung pwersa and our anchors or abutments are not very strong, what will happen? Siyempre, pwedeng mabitawan yung wire na magkakameron ng premature pre-stress force dun sa mismong concrete natin. So, halimbawa, hindi pa niya na-achieve yung mismong desired strength niya and nabitawan nung anchor yung mismong tire wire, yung wire natin, may possibility na pumutok yung konkreto natin kasi mabibigla yung transfer ng force sa kanya. Okay? Kasi yung resistance ng wire or yung friction between dun sa concrete natin and dun sa steel natin are not yet developed. Okay? Then pre-stress loss is greater. Ang sabi kasi kapag yung cable natin is released or cut, nagkaano siya ng more losses due to shortening no mismong mismong wire natin. Okay? So later may pag-aaralan tayong mga losses na isa sa losses na kino-consider natin for pre-stress is yung tinatawag nating shortening no na it happens both on concrete and sa steel natin. Okay? And also dito sa pre-tensioning system, yung pre-stress natin are also experiencing more shrinkage and creep losses. So kung ano yung creep and ano yung shrinkage loss, later di-discuss natin dun sa concrete properties natin. Okay? So this is yung isang system. Next is yung second system natin. Yung tinatawag natin post-tensioning system wherein yung pre-stress is induced after yung concrete natin are hardened. Okay? So ibig sabihin, ikakas muna yung concrete bago i-stress yung mismong tendons natin o yung wires natin. Unlike doon sa kanina, nauna yung pag-apply ng pre-stressing ng wires natin bago kinas yung mismong concrete natin. So, magkabaliktad naman sila ng process. Dito, papatigasin muna yung concrete o ikakast muna yung concrete. Then after casting, tsaka lang i-stress yung mismong wires natin. And when using this system, yung makikita natin dito, yung mismong wire natin has a sheet, no? A metal sheet, or minsan ang ang ginagamit natin dito is yung mga uh, anong tawag doon, yung uh, nalimutan ko yung term. So, yung meron siyang sinusuotan dito na material. So yung metal sheet nga na yun o yung tube, yan, itong duct, yung mga ano natin, PVC duct natin, okay? Na kasama yun dun sa kinakas dun sa concrete na once na nag-harden yung concrete, and then after natin ma-stress yung mismong wires natin, syempre pag na-stress yung wire natin, liliit yung cross-section niya. So pag lumiit yung cross-section niya, may voids na present dun sa duct natin, dun sa ducting natin, tsaka dun sa wires natin. So ang mangyayari after nun, before na i-cut yung mismong tendon natin, naglalagay tayo, nag-i-inject tayo ng bonding sa kanya, ng grout, cementitious grout, or minsan gumagamit ng wax or grease. Depende dun sa system, dun sa gagamitin ng contractor. Okay? So, ayan, when concrete has sufficiently hardened, the tendons or cable is transferred from the tendon to the member through anchorage wedges. Okay? So, ito yan, yung mga anchorage wedges natin. Then, the space between the tendon and the duct is filled with cement grout. So, may dalawang classification yung grouting natin. May tinatawag na banded na grout, and then meron tayong unbanded system. So, pag unbanded yung atin, ang ginagamit is wax or grease ang ginagamit niya as agent para mag-fill dun sa duct natin. And then, banded naman siya kapag cementitious grout yung gagamitin natin. So, anong pinagkaiba nila? Doon sa unbanded na na material o yung wax or grease, yung stress dun sa strand natin will be constant dun sa buong system natin kasi hindi na o-oppose ng mismong wax or grease yung performance ng buong wire natin o yung tendon natin dun sa system. Unlike kapag banded yung mismong material na nilagay natin o cementitious grout yung nilagay natin, yung stress dun sa strand natin, nag-change siya along dun sa length niya kasi nag-a-act siya as one unit na. So parang nagiging concrete na din siya. So sabihin, yung stress dun sa along the length ng wires natin will be distributed. So hindi uniform yung development ng stress natin doon. Okay? And then I also have an example video kung paano yung post-tensioning. So let me share ulit.
S&P Post-Tension Company Limited is a company operating business about designing, estimating price, and producing and installing post-tension, as well as giving advices about technical matters by proficient and highly experienced engineers and teams to respond satisfaction of customers with quality and punctuality. Step 1. Installing slab formwork. Step 2. Installing side formwork. Step 3. Placing lower reinforcement. Step 4. Installing anti-bursting reinforcement. Step 5. Placing lower reinforcement in column. Step 6. Installing punching shear reinforcement. Step 7. Determining position and placement of bar shear by profile height. Step 8. placing tendon and tied with bar share. Step 9. Installing anchorage and grout vent. Step 10. Placing top reinforcement and extra reinforcement. Step 11. Pouring concrete. Step 12. Removing side formwork. Step 13. Removing former. Step 14. Inserting block and jaws. Step 15. Stressing and measuring elongation. Step 16. Cutting strand end. Step 17. Filling socket with mortar. Step 18. Bleeding air for cleaning. Step 19. Grouting. Step 20. Removing scaffolds and back prop from excessive weight the floor can support. It starts from step 1 until the procedures are completed.
So yung na-witness na example is uh, pag post tension ng slab no on site. So yung nangyari sa kanya, kung mapapansin niyo baka malito tayo no, itong unang reinforcement na nilalagay sa kanya is yung rebars natin. So ito yung steel reinforcing bars ng mismong concrete ng slab natin ano. And then yung mga additional sa kanya is for yung critical sections natin for punching shear. Kaya nag-alcamer siya ng top and bottom. Ang important sa atin dito in pre-stressing will be yung mga ini-install na ito, yung bar chair. Kasi 'di ba ang profile ng mismong reinforcement natin, ng tendon natin is minsan hindi lang siya laging straight or hindi lang siya eccentric. There will come a time na parabolic yung shape niya or naka-harp yung kanyang shape kaya nagkakameron tayo ng change in elevation dito, and we can do that on site by providing mga bar chair na tinatawag. Tapos dyan nga nilagay yung mga itong mga ducts na pinatong dun sa ibabaw niya. Okay? So kaya kung papansinin dito yung profile niya, nag-change siya ng elevation, no? So depende doon sa behavior ng mismong structure natin. So parang sa bakal din yung consider sa kanya. Pag sa slab. Okay? And then after that, kung makapapansin nyo dito, naglagay siya ng reinforcement on the edge to control yung bursting. Kasi sa sobrang dami din nung in-install na pre-stressing wires, there's a possibility na when we stress yung mga tendons natin after curing, may possibility na mag-crack siya. So to aid yung cracking, and bursting dito sa side na to kasi this will be the area na pinakamalaki yung stress no dito sa mismong abutment natin, dito sa mismong end natin. Kaya naglagay ng reinforcement. And then ito yung duct na sinasabi ko no. Nasa loob na niya yung mismong reinforcement natin, and makita niyo dito meron tayong bar chair. So once na binuhusan na siya, then once na dito. Yan. I-remove na yung formwork niya. So, dito hindi pa stress yung mismong strand natin. So, tsaka pa lang siya i-stress, lalagyan siya ng marking to know kung saan natin ika-cut later on kasi pineasure naman siya habang hina-hydraulic siya dito sa part na to. Okay? So dito mapapansin niyo nag-move ng ilang length, ilang inches yung mismong length ng bars natin indicating na yun yung required na uh, lengthening or stretch para ma-achieve yung pre-stressing force na kailangan natin doon. And after nun, yun, nilagyan lang siya ng mortar to close yung mismong concrete. And then ito, elevation to ha. So, ibig sabihin parang kung ikakat mo yung sa loob, ito yung nangyayari sa kanya. So, ang una, lilinisin muna siya para wala siyang mga unwanted na pwedeng na humalo sa kanya, no? During nung nilalagay pa lang siya. So, yung lahat din ng entrained air is ini-eliminate bago siya lagyan o i-injectan ng grouting. Okay? So, sa grouting, dito, ayan na, yung after dun sa mismong reinforcement natin, yung lahat ng voids is finifill na niya hanggang maano natin yung indicator dito na puno na yung mismong duct natin ng grout. So kung puno na yung grout natin or nag-overflow na siya, meaning lahat ng voids dun sa inside ng duct are all filled na. So we can assume na all throughout ng length ng mismong duct natin are bonded na with our wire. Okay? Ayan. So, yung ibig sabihin yung duct is embedded na yun dun sa ating structure. So, after nun, dito, ni-repeat na lang yung cycle. Okay? Ayan. So, ayan yun. Let's go back. Okay? So, yan. So, yun yung sa post-tensioning. So, we observe na after curing, tsaka lang natin siya pini-pre-stress. Okay? Then, some advantages. So, post-tensioning can be done in factories and also on-site, especially yung sa slab na medyo malaki yung building, no? So, pwede tayong mag-post-tensioning on-site. Okay? The loss of pre-stress is less as compared to pre-tensioning system. Kasi pwede natin siya gawin on-site. So, yung pwedeng losses niya on travel will be lesser na. Okay? Then this method is used for large spans and heavily loaded structures. Kaya do sa bridges natin, usually post-tension siya. So yung mga girder na ginagamit o mga culvert boxes or yung um, mga nilalagay mismo sa bridge structure are all post-tension kasi kaya niya mag-span on a larger scale compared dun in comparison dun sa pre-tensioning natin na small members lang yung kaya. Then disadvantage naman niya is mahal siyang gawin kasi yung mga additional attachment natin like for example yung nilalagay natin dun sa end natin. So yun yung kailangan natin consider and also yung duct o yung sheeting na ginagamit natin will cost greater compared dun sa pre-tension system natin kanina. Okay? So the main comparison of the two are shown below. So number one, for pre-tension, done siya in factories. So pwedeng may precast fabrication area tayo. And kay post-tensioning naman, pwede siyang on factories, pwede din siyang on-site. So dual purpose siya. No? Mangyayari kasi kay pre-tensioning, pag ginawa natin on-site, syempre kailangan, di ba, i-stress muna natin siya, tapos kailangan nating i-cast yung concrete. So, ibig sabihin, hindi mo siya pwedeng galawin while nag-cure siya. No? Unlike kay post-tensioning, after curing niya, tsaka lang siya pwedeng, tsaka mo lang siya i-stress. So, pwedeng mag-focus kayo dun sa other activities while on-site, dun sa post-tensioning method. The number two, small sections are to be constructed kapag pre-tensioning. And then for post-tensioning, size of member is not restricted, no? So, kaya yung bridges nga natin, which dito sa Philippines, nag-span siya ng 30, 40, 45, 50 meters, no? Ang isang span ng bridge. Yun yung kada pile, no? Kada pier ang tawag. So, yun yung ginagamit. And then also, number three, loss of pre-stress is more when we are using pretension. So, kung sa pretension is about 18%, kay post-tensioning is about 15% lang. Okay? So, bakit mahalagang malaman ito? Dahil nga, di ba si pre-stress is ginagawa natin to convert yung ating tension side ng concrete natin into a compressive material. Kaya yung pre-stress, kailangan natin para ma-change siya or magamit natin yung section na yun, di ba? From our previous discussion. Kung mawawala ng pre-stressing yung mismong wire natin o yung mismong system na pre-stress concrete natin, magiging babalik tayo doon sa dating condition na mababawasan yung member natin, okay, ng strength. Okay, then number 4, it is cheaper because the cost of sheeting is not involved. Wala tayo ng mga ducts na ginagamit. Unlike sa post-tensioning, kailangan yun kasi after casting tayo nag-stressing. And then number 5, more reliable and durable than pre-tensioning kasi mas control yung environment mo. Nasa isang fabrication area ka. Unlike kapag sa post-tensioning, there are other factors, and one of this factor is yung anchorage mechanism niya na depende kung gaano katibay yung mismong ends natin. Okay? So, ayan. So, yan yung dalawang system natin. Then, yung ginagamit natin na system dun sa ends nung dalawang tensioning method natin are tatawag natin jacking system. So, this is the fundamental component of a prestressing operation. So, yung jacking system natin is yung nagbibigay o nag-a-apply ng load dun sa mismong wire natin. So, sila yung nag-exert ng force. Sila yung nag-i-stretch, nag-pre-stress yung mismong wires natin. So, gumagamit tayo ng hydraulic jacks. So, kung makita natin dito, merong gauge siya. So, yung pressure dun sa, na ina-apply dun sa mismong wires natin at the end are very controlled kapag gumagamit tayo ng hydraulic jacks. And yung strength niya has a capacity of usually 10 to 20 tons. So imagine 20,000 kilograms. Okay? And can produce stroke from 6 to 8, 6 to 48 inches. So ilan ang 48 inches kapag gano? So 48 is around 1.2 meters, no? Yung mismong yung less lengthening ng mismong wire natin. Depending whether pre-tensioning or post-tensioning yung ginagamit natin. Okay? And then, okay, so yan yung sa mga system natin. Now, we can now go do sa property ng material natin. So, we have here materials natin for pre-stressing. So, for today, we will just discuss yung concrete, which is the major constituent ng pre-stress concrete natin. Kasi main nag-i-induce ng compressive stress or nagko-control ng compressive stress natin is yung concrete. Okay? So, yung pag pre-stress design, meron tayong tinatawag na ideal concrete din. So, ito yung according to Nawi na 4 characteristic na kailangan ma-achieve ng concrete natin to have an ideal pre-stress element. Okay? So first is the concrete has to be resistant to weathering and chemicals, no? And this can be achieved when we control yung proportion natin. So when we say control natin yung proportion, ibig sabihin yung water cement ratio natin should be low. Meron tayo dapat proper curing ng material natin. Yung aggregate natin should also be controlled. And dapat yung admixture na ginagamit natin in combining our concrete are based from the design na pinrepare talaga natin for the use of the building ng paggagamitan natin ng pre-stress element na yun. Okay? Then should also have resistant to deterioration or to wear. And ma-achieve to kapag meron tayong controlled material quality control, such as again water cement ratio is controlled, meron tayong proper curing time, meron tayong homogeneous concrete, no? So ibig sabihin dapat yung concrete natin as much as possible is dapat place siya at once lang, hindi yung mga pinuputol natin. Dapat ay um, as siya homogeneously. Okay? Then dapat high strength din siya. And then yung aggregate natin should have a good surface texture, no? Okay? Then for strength, ma-achieve natin sa strength when we control yung placing and curing natin. So, kailangan meron tayong good quality ng cement, okay? Low water cement ratio, meron tayong optimal cement content, meron tayong magandang aggregate na sand and coarse aggregate. Um, yung grading natin should be good and vibration and dapat very low yung air content natin dun sa mismong concrete natin or yung voids dun sa concrete natin should be lesser. Kasi yung voids natin na yan yung sisimula ng cracking. Kasi once na na-stress na yung concrete, ang tendency niya is ang una niyang i-break is yung mga voids o yung mga force, no, ng mismong concrete element natin. Okay? Then last is economy, which can be achieved when we control yung pag-handle ng mismong element natin. So dapat yung mga maximum aggregate size natin should be controlled. Meron tayong good grading ng aggregates. We should maintain yung minimum slump, minimum cement content. Meron tayong optimal automated plant operation and also yung ating admixtures and yung air content ng concrete natin should be controlled. So usually this characteristic is being controlled by quality engineers sa site, no? So if ever you will be part of it, your responsibility is to check yung mga design na prepare for such structure and also um, consider tong apat na to as your main factor to have an ideal concrete. Okay? So the mechanical properties of hardened concrete can be classified into two categories. So meron tayong tinatawag na short-term properties and long-term properties. Okay? So short-term or instantaneous properties na-achieve ng concrete dun sa early life niya. So upon siguro after niya ma-achieve yung 28-day strength niya and then ito yung mga instantaneous properties na pinopossess niya. We have yung compressive strength niya, tensile strength, shear strength, and then stiffness na measured siya in terms of modulus of elasticity. And then we have also yung long-term properties niya which are creep and shrinkage. Okay, so discuss natin isa-isa yan. So let's start with short-term or instantaneous properties muna ng concrete natin. So for concrete, yung compressive strength natin will depend do sa type ng mix natin, ng property ng aggregate and yung time and quality of curing. So, si compressive strength may be obtained depende sa design. So, up to 20,000 PSI or more. So, 20,000 PSI is how much? Around 137 MPa, no? Pero pag ginagamit natin yung normal weight concrete, usually ginagamit natin on site is 28 MPa lang o 4,000 PSI. So, yung mismong design ng concrete natin can achieve very high amount of compressive strength depende dun sa requirement ng project. Okay? And according to NSCP, to test for compressive strength ng mismong mix natin, we should prepare at least the following. So, according to section 426.12.1.1, a strength test shall be the average of strength of at least 2 150 by 300 na cylinder or at least 3 na 100 by 200 mm na cylinder. So usually, ang ginagamit on site is yung 100 by 200 na size, no? na kinukuha yung sample na yon kapag nasa site kayo from the track mixer, no? Before mo ipag-go na ibuhos sa yung track, yung laman ng konkreto sa track mixer, kukuha muna kayo ng random sample. So sa sa isang conveyor, kung meron kayo, maghihingi kayo ah, dun sa pahinante ng track mixer ng sample, and then you will test it for slump. Iko-control mo yung slump para sa workability, and then itetest mo din yung kanyang um, yung pag-create ng sample natin. So dito at least 3 sample must be taken prior to testing at 28 days. Okay? So minsan sa site nire-require na at 7 days, itetest mo siya at 21 days, at 28 days. Depende kung sa requirement. Merong 3 days, merong 1 day. Depende do sa design ng concrete natin. And then yung compliance or acceptance criteria natin is dapat yung mismong test natin should be within do sa design amount natin. So yung compliance natin, strength level of concrete mixture shall be acceptable if 1 and 2 are satisfied. So number 1, every arithmetic average of any 3 consecutive strength equals or exceed yung F prime C natin. So kung greater than, halimbawa, design natin is 28 MPa, dapat more than 28 MPa yung makuha natin. Pero there should be no less than or more than 3.5 MPa. So kung 28 MPa minus 3.5, so dapat wala nang mababa sa 24.5. Okay? Dun sa mismong strength natin. Or dito, or mag-exceed naman siya ng 0.1 F prime C if yung F prime C natin exceeds ng 35 MPa. So halimbawa 35 MPa yung design natin, and then yung 1.1 nun is 38.5. So parang trivial na din kapag lumampas siya ng strength na yon, kasi ang concrete during curing niya, nagde-develop talaga siya ng strength niya, no? Na minsan dahil dun sa gamot na ginamit, sa admixture na ginamit, akala natin sobrang tibay nung mismong concrete natin, pero upon curing ng ilang araw pa, bigla na lang siyang bababa yung strength niya. Okay? So dapat i-control natin yung, o i-accept natin yung concrete natin when it satisfies both this condition na 1 and 2 natin dito sa section 426.12.3.1 ng NSCP. Okay? Then bukod sa compressive strength, we should also test yung kanyang tensile strength. Na si tensile strength, ang strength niya, sabi nga natin, is relatively low compared nga dun sa compressive strength natin. Di ba sabi nga natin ng discussion last time, almost or approximately 10% lang ng mismong strength ng design natin, ng compressive strength natin, yung tensile strength natin. And si tensile strength is na-test siya using also the same samples na 100 by 200 na sample using 3-point loading o tinatawag nating Brazilian test. So ito yung Brazilian test na tinatawag, no? Na yung testing natin is yung cylinder natin kailangan mag-splitting siya na ganito. Okay? So makikita natin meron siyang plywood on top and bottom. Then yung mismong member natin, yung mismong sample natin is along mo sa longitudinal side niya yung loading. Okay? So for members subjected to bending, the value of the modulus of fracture or FR rather than the tensile splitting strength F prime T is used in design. So si NSCP, bukod dito sa bending test na ginagawa to calculate yung tensile strength ng concrete, we are advised to use yung NSCP requirement natin, which is yung modulus of rupture natin na FR taken sa formula na to. Yung 0.62 gamma square root of F prime C. This is in MPa. So yung gamma natin, depende kung anong klase ng concrete. For normal weight concrete, our gamma is 1.0. So if you want the other values for gamma, you can check out your NSVT copies. Okay? So, ito yung sa tensile strength. Okay? Then next is yung shear strength. So shear strength is more difficult to determine experimentally uh, in opposed to sa other tests because of the difficulty in isolating shear from other stresses. Kasi usually combined flexure and shear yung nangyayari sa atin kapag beam, no? Kaya control of structural design by shear strength is significant only in some cases only. Kaya kung susundin natin yung limit ng code, once na na-provide naman natin yung required shear reinforcement natin, in-expect natin na yung beam natin will perform adequate for shear. Okay? So, shear stresses must ordinarily be limited to continually lower values in order to protect the concrete from failure in diagonal tension. So, itong mga sample na to may have I'm not sure if meron siyang stirrups, no? Kasi it's not seen on the photograph. Pero to control those cracks, by principle ng ating stirrups, yan yung kanyang kinokontrol. Mangyari sa kanya, sabigan natin yung ganyang failure na due to shear. Okay?
Okay, okay. Anong kasunod?
Okay.
Paano pag 0 point?
Busy. Okay. Next. Modulus of elasticity. So, di ba na ano natin yung modulus of elasticity natin as the slope ng ating stress strain curve natin. And kay NSCP, para doon sa concrete natin, we have a formula to identify yung modulus of elasticity ng concrete natin. So for values of unit weight between 1,440 and 2,560 kg per cubic meter, ito daw yung gagamitin nating formula. So ito yung detailed formula. Okay? And then for normal weight concrete, ito yung simplified formula natin na 4,700 square root of F prime C. Okay? So you can see here, meron tayong, ito yung nangyayari sa stress strain diagram ng concrete. Okay? So there are, may parts siya na elastic, pero may certain portion sa kanya na yung performance niya will be parabolic na. Kung ganito. Kaya ang ina-assume natin yung performance ng mismong concrete natin when subjected sa stress strain curve is parabolic yung shape niya. So from the origin, para makuha lang natin yung elastic na modules of elasticity natin, naglalagay lang tayo ng tangent line. So ito yung tangent line na yon dito. Tangent line with the origin. So yung tinatawag natin ECT or yung initial slope ng stress and strain diagram natin. Then we have yung EC natin na 0.45 siya ng F prime C. At tapos, naka-second siya. Second line kasi from the origin and dun sa point na kung saan mag-intersect yung 0.45 F prime C na stress. Okay? So yung sa code natin, gumagamit siya ng second modulus, itong second line natin na EC. So yung kinakalculate talaga natin is mula dito sa point ng 0.45 F prime C, which is considered dito sa derived equation natin by the code. Okay? Okay, next. So yun yung sa short-term properties natin. Now we go to sa creep. Okay? Creep is also known as yung material flow natin and defined as the increase in strain with time due increase in strain with time due to sustained load. So ibig sabihin stress maintain ang pinag-uusapan natin kapag creep. So ibig sabihin once we apply stress dun sa mismong element natin dito as we increase yung stress natin, there is a point dito sa ano natin na kahit i-sustain lang natin yung load natin, gawin nating fix yung loading natin, in long term, yung fixed load natin will incur ng um, deformation pa din or strain na magko-continue yung strain natin. So yung difference nung point o yung strain kung saan tayo nag-apply ng isustain natin na load o gagawin natin constant yung load minus dun sa kung saan mag-intersect dito sa long-term curve flat ng stress strain diagram natin, yun yung tinatawag nating creep. Okay? So dun dito sa ating elastic range, habang hindi pa niya na-achieve yung yielding dun sa concrete natin, meron siyang tinatawag na instant elastic shortening. Okay? Then once na exceed na niya itong E sub O natin, itong E sub O natin for concrete is how much? So ang strain natin is 0.003 according sa design natin, di ba? So kapag yung strain natin is greater than 0.003 na, yun yung time na magkakameron na tayo ng creep. Okay? Long term. So yung difference between dun sa strain na consider natin minus yung controlling creep natin, controlling strain natin, yun yung creep natin dito. Okay? So again, creep is accounted by looking at a theoretical long-term curve dito na ang slope niya is called EC effective. Kung makikita natin dito, nag-pass through din tayo ng tangent line from the origin and dun sa curve natin na meron tayong effective na may formula yan. So if ever needed, nasa code naman yung formula niyan. Then creep can be determined only by deducting yung elastic strain natin from elastic strain and shrinkage strain from the total deformation. So meaning, para makuha yung yung creep strain natin, from the total deformation, ma-minus natin yung elastic strain natin, shrinkage strain, then yung creep strain yung matitira. Okay? Then more on creep. So creep is not completely reversible. So if a specimen is unloaded after a period under a sustained load, an immediate recovery will happen. So dito, halimbawa, continuous yung loading natin. So more than dun sa nag-experience na siya dito ng elastic deformation. Nandito at this point, nagkameron tayo ng unloading. So mangyayari doon sa strain natin will go down. Okay? Yung sudden movement ng unloading natin is tinatawag na immediate recovery. So, although si creep is hindi niya may babalik dun sa original strain niya, yung mismong concrete natin, pero once na halimbawa yung load natin is removed from our member, yung unloading period na yon will experience tong tinatawag nating instantaneous recovery, okay? Or immediate recovery na tinatawag natin strain E2, okay? Epsilon E2. And then from that point, magkakameron ng further reduction ng mismong strain natin hanggang magkameron ng creep recovery. So from dito sa point nito, kakameron tayo ng creep recovery hanggang maging constant na yung mismong strain natin sa structure natin. Okay? So effect ng creep natin is it increases the deflection of beams and slab and cause loss of pre-stress kapag sobrang excessive ng creep natin. And then also the initial eccentricity kapag halimbawa RC column yung meron tayo is nag-i-increase siya with time resulting sa transfer ng compressive load from the concrete to the steel, no? Or kapag halimbawa nag-yield na yung mismong steel natin, wala na magki-carry ng load natin. So, ang may stress na is concrete na. Okay? So, eventually, mag-lead siya sa failure kapag na-overstress na yung concrete natin. Okay? Then yung isang condition, kung si creep is stress maintained, yung isang condition, tinatawag natin relaxation naman. Dito naman, strain maintained naman tayo. So, sabihin, kapag yung strain natin, hineld natin constant. So, like for example, dito, balik tayo dito sa curve natin. Meron tayo ditong point kung saan yung stress natin is at this point, FC0. So yung stress natin at this point. Tapos, hindi na nag-increase yung, nag-reduction tayo ng stress, binabaan natin. So yung mismong strain natin is held constant. So hindi siya gumagalaw. Yung difference from the maximum or the larger value of stress minus dun sa lower value ng stress natin is called the relaxation. So pag ginraph natin yung stress time curve niya, so from the maximum or larger value ng stress natin, pag in-apply natin yung relaxation o pinakita natin yung relaxation, may sudden movement ng stress natin, which eventually, nakalagay nga dito, hindi held natin constant yung mismong strain natin o hindi na siya nag-elongate. Okay? So, if we keep the strain constant over time, it will take less stress to maintain that strain. Okay? Kaya nagkakamero ng less stress required to maintain that. Okay? Next is yung shrinkage na tinatawag. So, yung concrete losses moisture with time and decrease in volume. And this phenomena is called shrinkage. Okay? So the amount of shrinkage depends on the following. First one is sa composition ng concrete natin. So di ba si concrete is primarily may water siya. So yung water content natin and then yung stiffness ng aggregate natin. Okay? So depende dun sa property ng materials na ginamit natin. Also sa elapsed time. Okay? Depende kung gaano katanda na yung structure. So, usually yung older structure are mas less na yung kanyang shrinkage or asymptotic na yung shrinkage niya kasi nga kumbaga na maintain na na-attain na niya yung kanyang yung maximum strength niya. Kaya hindi na nag-less o hindi na nagkakamero ng moisture dun sa loob niya. Okay? Then we have yung sa ambient condition. So, kapag halimbawa yung climate is humid o very hot yung climate or dry yung climate, eventually, pag mas mainit, mas mabilis ma-loss yung moisture ng concrete natin. Okay? So, mas mabilis mag-evaporate yung water. Then sa volume surface ratio natin, so ibig sabihin kapag more exposed area yung naka-present sa atin sa exterior, mas mabilis yung drying ng water content natin. Okay? Then kapag halimbawa na sobrahan yung pag-shrinkage ng mismong konkreto natin, that leads to cracking dun sa ating structure mismo. Okay? Then there are two types of shrinkage. Yung tinatawag nating plastic shrinkage and drying shrinkage. So plastic shrinkage occurs during the first few hours after placing fresh concrete in the forms. So kung papansin niyo to, meron siyang dash line dito. So yung autogenous shrinkage na yan, parang plastic shrinkage din yung definition niya. Then meron dito at a point dito kung start of drying na siya. Okay? So dito na mag-start yung drying shrinkage natin sa point na to kapag na-reach na itong point na to. Okay? So as yung age ng concrete natin again gets older, yung shrinkage natin become asymptotic na. So makikita natin dito yung strain natin dito. From time, dito malaki yung strain natin. Pero pagdating dito, asymptotical na yung mismong strain natin dito sa area na to. Yung other type of shrinkage, yung drying shrinkage na tinatawag, occurs after the concrete has already attained its final set and a good portion of the chemical hydration process in the cement gel has been accomplished. Okay? So kapag microscopically speaking kasi, yung concrete natin is ano siyang gel-like component na once na yung hydration process natin is good, yung shrinkage natin will be eliminated. Okay? Or maliit yung value ng shrinkage natin. Okay, and then we have formula for shrinkage. So for standard condition or humidity, or yung humidity natin is around 40%. For moistured concrete at any time T after age 7 days, ito daw yung formula natin. So yung formula is multiplied by the ultimate shrinkage strain na given siya as 800 times 10 to the negative 6 kapag hindi siya given ng supplier. Okay? So, ibig sabihin for age more than 7 days tong formula to. And then for steam cured concrete, age 1 to 3 days, ito yung strain natin na yung ultimate shrinkage strain niya is given as 730 times 10 to the negative 6 kapag hindi available or given ng mismong supplier yung kanyang value. Okay? Next, we have yung mga maximum permissible stresses natin of concrete. So, itong table na to can be seen do sa NSCP 2015 natin. So, nag-snippet lang ako. So, itong first one is classification ng prestressed structural member natin. So, depende do sa strength. So, yung flexural member natin can be classified based dun sa kanyang F sub T. Okay? So, uncracked siya kapag yung F sub T is less than 0.62 of F prime, the square root of F prime C. It can be transition between uncracked and cracked. So, 0.62 na F prime C less than FT. Okay? So, yan yung range. So, check nyo na lang dito sa table na to yung value ng FT with this following ranges. Okay? And we also have different stresses kapag at transfer siya, no? Yung kapag at transfer condition or final condition na siya or at service condition siya. So we have first yung para sa compressive stress limit natin, kapag simply supported members, meron daw tayong 0.7 na FCI. All other locations 0.6. Then for tensile stress natin, so this should be tensile stress. Yung limit natin is 0.5 F prime CI or 0.25 for all other locations. Okay? So, ito naman magagamit na natin to once we have yung example na natin na design. Okay? So, magre-refer ulit tayo dito sa tables na to when we go back to sa pag-check ng design natin later on. Okay? Then last is kapag yung concrete stress natin at service load. So, ito yung kanyang limit. So, kapag yung pre-stress plus sustained load yung location natin, we have 0.45 F prime C, I. And then pag yung pre-stress natin plus total load, we have 0.6 F prime C, I. Again, the use of this table will be further enhanced dun sa application natin ng examples. But for now, this will be the end ng ating mga maximum permissible stresses for concrete. Okay? So, next session, we will discuss yung sa non-reinforced, non-pre-stress reinforcement natin, yung mga rebars natin, and sa pre-stress bars natin and wires, and also dun sa methods of calculation natin. So, yung load balancing method, yung dalawang type pa. Okay? So, we will discuss that on next meeting. Okay? So, regarding the exam, I think we will have to adjust yung examination natin dito for this subject. Okay? So, this ends our lecture for today. So, more on, wala pa masyadong calculation, no? Pero next meeting, we will have example calculation performing yung methods na pag-aaralan natin in calculating for the stresses ng mismong structure na given sa problem. Okay? So, if you don't have any more questions, this ends our lecture, and I hope to see you guys next meeting. Okay?
Thank you po, sir.